Okay, in this video, we're going to do number 1 from the 2022 Calc A, B, and BC exams. So they both had the same first question, and it's kind of like a working with a rate of change problem. So let's take a look at what it says. From 5 a.m. to 10 a.m., the rate at which vehicles arrive at a certain toll plaza is given by A of t, which is 450 root sine of 0.62 t, where t is the number of hours after 5 a.m., and A of t is measured in vehicles per hour. Traffic is flowing smoothly at 5 a.m. with no vehicles waiting in line. All right, so for part A, we want to write but do not evaluate. That's really interesting to me. An integral expression that gives the total number of vehicles that arrive at the toll plaza between basically t equals 1 and t equals 5. All right, so we are trying to figure out the total number of vehicles that arrive. That would be an integral of the rate at which they're arriving, and it turns out in the problem, the rate at which the vehicles arrive is A of t. So for this problem, all we really want to do is the integral from 1 to 5 of A of t dt. And since the function is named A of t, you don't need to write 450 root sine of 0.62 t. We don't have to evaluate this. That's literally all we needed to do. I feel like that's a problem where they try to get you to understand how the problem is working. So let's move on to part B and see what we're now going to do with this idea. All right, part B. Find the average value of the rate in vehicles per hour at which vehicles arrive at the toll plaza from t equals 1 to t equals 5. So the average value of the rate. So average value in general is integral over interval. So we're going to do the integral of the function that gives us the rate divided by the interval on which we're searching, which is from 1 to 5. All right, so that's going to be the integral from 1 to 5 of A of t dt, which I guess is why you didn't have to do it in part A, because we're just going to calculate some stuff here anyway, divided by 5 minus 1. So the integral of the rate over the interval, which is 5 minus 1. This is a calculator question, so we're going to get our answer by storing A of t. Maybe you don't store it, maybe you just use it. It's up to you. I always store functions. Storing A of t, and then doing the integral over the interval, I got 375.537, and that's going to be the units for the average value of a function are the same as the units of the function. So A of t is measured in vehicles per hour. So the average value of A of t is also vehicles per hour, which is just further evidence that we've done this or set it up correctly, because our answer should be in vehicles per hour. All right, pretty good. Next up, is the rate at which vehicles arrive at the toll plaza at t equals 1 increasing or decreasing? So we're looking for if the rate is increasing or decreasing. The rate is A of t, right? So this was our rate. We're looking for whether the rate is increasing or decreasing. I'm going to find A prime and evaluate it at 1. But again, it's a calculator question, so I need A prime of 1. I'm not doing that by hand. Even if I did, I wouldn't know sine of 0.62 or cosine. So I've stored the function, and I found the derivative of that function at 1. I got approximately 148.947, so I'm going to write that down. That's greater than 0. And now I'm just going to write up my solution. So I'm going to say, since A prime of 1 is greater than 0, the rate at which vehicles arrive at the toll plaza, and then that rate is A of t, so I'm going to say comma A of t. I don't think you need that because it's, it is the rate, is increasing because greater than 0. So is increasing at t equals 1. And then t equals 1 was 6 a.m. I'm never sure what they mean when they say, they didn't really ask us to give a context. They asked for a reason, but t equals 1 is that's the math part. 6 a.m. is the real world part, so I thought I should throw it in. All right, let's take a look at the next part, which is a line forms whenever A of t is greater than or equal to 400. Okay, so it's not always greater than 400, so we're going to have to figure that out. The number of vehicles in line at time t for A is less than or equal to t is less than or equal to 4 is given by n of t, which is the integral from a to t of a of x minus 400 dx, where a is the time when the line first begins to form. So the first time that we hit 400 cars is a. That's a value of a. To the nearest whole number, find the greatest number of vehicles in line at the toll plaza in the time interval from a to 4. Justify your answer. This to me sounds like a candidates test problem. And so that's basically how I'm going to choose to do it. We're looking for the absolute maximum on a closed interval. Candidates test for sure. All right, so first of all, I need to know when a of t is greater than or equal to 400. So what I've done is I've graphed a of t. That picture is really small. I can make it bigger, but then it might obscure something later on. But you know what? I'll just do this. There we go. Okay, so that's a little bigger. So a of t is first equal to 400 at 1.46937. So what I've done is I've written a of t equals 400, gives t is approximately 1.46937. Now I know there's another value. That value is going to come into play in a second, but not right now. And I'm going to say this is a because that's the first time, right? So I'm setting that equal to a. Now, I want to use a candidates test. To use the candidates test, I need n to be continuous. So I'm going to write up how I set up the candidates test every time. N is continuous. I'm not going to justify that because a is continuous on the interval, and so n is differentiable, and differentiability implies continuity. There's, I think, no way they wanted you to go through all those hoops on this. So I'm just going to say n of t is continuous, therefore the absolute maximum is either at an end point or at a critical point. So the end points are a and 4. Now we're going to need critical points, and it's not like immediately obvious, so I think that we should show how we're getting the critical points. So I'm going to say that n prime of t is a of t minus 400, second fundamental theorem, equals 0, and then I need to know when that happens. Well, that happens, so I wasn't thinking when I did the problem. That's obviously going to happen at 1.46937 and at 3.59771, but I not accidentally, I just did it again. And this again is really small. Let me beef this up a little bit. Okay, so 3.5977 is the critical point on the interval. So I said t is approximately 3.59771, and I'm setting that equal to p because I don't want to write that number again. Okay, so after I did that, what I'm going to do is make a table of values for the function n, and I need to evaluate at the endpoints, which are a and 4, and at this critical point, which I've called p. So my table looks like this. It's just t and then n of t. The values I want are at a, p, and 4, and then I use the calculator to get those values. So because I had already named the function a, the calculator wouldn't let me store the value as a, so I just stored it as a1. So that's why I've defined n of t to be the integral from a1 to t of a of x minus 400. And you can see that I got 0, I got 71, and I got 62 because the question is to the nearest whole number. So 71 is our maximum, so let's write that up. Therefore, the max number of vehicles on a to 4 is 71 vehicles. So we have used the candidates test. I didn't say by candidates test. You don't usually need to name it. Perhaps I should have said by candidates test, the absolute max is at the endpoint or the critical point. That'd be a better answer, but it's not what I did. All right, so that was number 1 from 2022. Okay, this is going to be number 2 from the 2022 Calc BC exam, and it's a vector/parametric equations problem, and it's pretty straightforward, so let's see. Particle moving along a curve in the xy plane is at the position x of t, y of t at t greater than 0. The particle moves in such a way that dx dt is the square root of 1 plus t squared, and dy dt is the natural log of 2 plus t squared. So already I'm grabbing my calculator and I'm defining those functions so that I can use them. At time t equals 4, the particle is at the point 1, 5. So this t equals 4 thing is going to be really important. It's not t equals 0, it's not t equals 1. We're starting at t equals 4, and we know we're at the position 1, 5. All right, find the slope of the line tangent to the path of the particle at time t equals 4. So we know that dy dx is going to be equal to dy dt divided by dx dt. And then we're going to evaluate that at t equals 4. This is a calculator question, so we're going to let the calculator do the work. Here's a screenshot. I defined dx of t, I defined dy of t, and then I'm just doing dy of 4 over dx of 4. So the exact value is natural log of 18 over 17. I prefer to always use decimals on these things, so I'm going to say approximately 0.701 and move on. Next part. find the speed of the particle at time t equals 4, and find the acceleration vector of the particle at time t equals 4. So we're doing two parts here. They almost always put these two things together. I'm not really sure why. I guess they think people confuse them or something. I'm not sure. Anyway, speed. So speed is going to be, it's the magnitude of velocity, if that's how you think about it. I'm going to write it as the square root of dx dt squared plus dy dt squared. And then we're going to evaluate this at t equals 4. I'm going to use the calculator, but I'm going to do one screenshot. So I'm going to write the work for the acceleration vector first. So acceleration vector is going to be, so at 4, we're going to do the second derivative of x with respect to t, comma, the second derivative of y with respect to t. And then, so I don't know, like on particle motion, you're supposed to connect velocity to acceleration, acceleration and velocity to position. Here, I think we did that, right? I think we've said that it's going to be the second derivative, comma, the second derivative. I think this is fine. We'll find out in the future if it's not, and I'll put a comment if it's not. So at t equals 4, here is my screenshot because I've already defined dx of t and dy of t in the previous part. I just need to find the square root of dx of 4 squared plus dy of 4 squared, and I get 5.035. And then I found the derivative of dx at 4, the derivative of dy at 4, and I'm going to write that in vector form. So 0.970, I always go 3 decimals no matter what, and then 0.444. All right, next part. Find the y-coordinate of the particle's position at time t equals 6. So now it's going to be really important that we're starting at t equals 4. So if I want to find y of 6, what I need to do is I need to know where I'm starting, right? I'm starting at y of 4, and then I'm going to add the displacement of y, which is the integral from 4 to 6 of y prime of t dt. So it's where we're starting plus the displacement. Definitely my favorite way to use the fundamental theorem. So I decided to write another step here. I don't know that this is necessary. It's calculator. You could probably just go, except y of 4 is not like clearly defined. So maybe it is better to do this like 5 plus. I'm sure you'd get the points either way. Calculator, I used the calculator on this. I forgot to put in the screenshot. I just did literally 5 plus the integral from 4 to 6 of dy of t. And the calculator gives me 11.571. And finally, find the total distance the particle travels along the curve from time t equals 4 to t equals 6. All right, so distance traveled is the integral of velocity. No, it is not. Distance traveled is the integral of speed. Speed is the magnitude of velocity. So we're going to be doing the integral from 4 to 6, because that's our time frame, square root of, because we're finding the magnitude of velocity here, it's going to be dx dt squared plus dy dt squared. And then I'm going to close up this square root sign, and I'm going to put a dt. Then I grab my calculator, I do the integral from 4 to 6 of that, and I get approximately 12.136, and that's the entire problem. It's very straightforward. Okay, in this video, we're going to do number 3 from the 2022 Calc AB and Calc BC exams. They had the same problem, number 3. It's going to be a problem where you're given a graph of the derivative and asked all kinds of questions about it. So let's see what we can do. Let f be the differentiable function with f of 4 equals 3. On the interval from 0 to 7, the graph of f prime, the derivative of f, consists of a semicircle and 2 line segments as shown in the figure. All right. We want to find f of 0, find f of 5. This is a fundamental theorem of calculus problem. So to find f of 0, what I'm going to want to do is take the value that I know, which is f of 4, and then because 4 is bigger than 0, I'm going to have to subtract the integral from 0 to 4. Like normally, you would say that the integral from 0 to 4 is, the integral from 0 to 4 of f prime is f of 4 minus f of 0. But since we know f of 4, we want to go backwards to f of 0. We have to subtract off that definite integral. And now this is kind of an area problem. So that semicircle has a radius of 2. A circle with a radius of 2 has an area of 4 pi. I don't know, but then we're taking, oh, well, that's weird. that I wrote like the wrong thing there. I should have written negative 2 pi there. I'm going to fix that. I'm going to try to fix that. The full circle would have had an area of 4 pi. This is half of it, so this is 2 pi, and we're below the axis, so negative 2 pi. All right, so apologies. Hopefully this goes better going forward. I'm pretty sure it will. We'll see. So f of 0 is going to be 3 minus the negative 2 pi that we found. And so that's just going to be 3 plus 2 pi. So that's f of 0. Now next we need to find f of 5. F of 5, we know f of 4, so we're going forward this time. So that's going to be f of 4 plus the displacement from 4 to 5, so plus the definite integral from 4 to 5 of f prime of x dx. All right, and then I'm going to again look at my graph. This is half of the square that has an area of 1, so that area is going to be 1/2. And so we're going to say f of 5 is 3 plus 1/2, which is 3.5 or 7/2, whichever one you want to use. All right, let's take a look at part B. Find the x-coordinates of all points of inflection of the graph of f on 0 to 7 and justify your answer. All right, so this is the graph of f prime that we are shown, which means all of the places that f prime goes from increasing to decreasing or decreasing to increasing are the points of inflection. So at x equals 2 and at x equals 6, I'm going to use a slightly different justification though because I prefer to use this. So I'm going to say f of x has point of inflection at x equals 2 and x equals 6. My reasoning is going to be because f prime has relative extrema at those values. That's the easiest way to justify it. Otherwise, I'd have to say because f prime changes from decreasing to increasing or increasing to decreasing at those points. Both justifications are good. I just prefer this one where I talk about relative extrema. I really like that justification. I use it whenever I can. All right, let's take a look at the next one. Let g be the function defined by g of x equals f of x minus x. On what intervals, if any, is g decreasing between 0 and 7? Show the analysis that leads to your answer. All right, so I'm going to have to find the derivative and then figure out when the derivative is negative, right? Because that's how you figure out when something is decreasing. So g prime of x is going to be f prime of x minus 1. So if g of x is decreasing, I would need g prime to be less than 0. So I need to figure out what's going on there, right? G prime is less than 0 would mean that f prime is less than 1. So now I need to look at the graph and figure out where f prime is less than 1. So if I go to the graph, I'm going to add in the line at y equals 1 because I have the graph of f prime. I just need to know where this graph is less than 1. And now I can visually see it, right? This intersection point is 5, 1. And until I get to that intersection point, f prime is below 1. So that's the region on which g is decreasing. So now I'm just going to write that up. I'm going to say that g is decreasing on the interval from 0 to 5. And then my reasoning for that is going to be because g prime is less than 0 on that interval. So I did the analysis though, right? You can see I showed g prime is less than 0 implies that f prime is less than 1. That's my reasoning there. So I would be showing all of this work. Obviously, when I do these problems, I show exactly what I would show on the AP exam if I was taking it. So all of this would be my work. Let's take a look at the next part. For the function g defined in part C, so that was g of x is f of x minus x, find the absolute minimum value on the interval from 0 to 7, justify your answer. So we need the value, we don't just need the coordinate. So let's see if we can figure this out. So g of x is definitely a continuous function. So I'm going to say g of x is continuous. Because it's continuous, the absolute minimum is going to occur at either an endpoint or at a critical point. And the reason that that is true is the candidates test. So you don't usually need to name the candidates test, but I'm naming it anyway. So by the candidates test. All right, now we already know that g prime is f prime minus 1. But we need the critical points, right? So we need to know when that is equal to 0. That's equal to 0, we could visually see because we did the work in the previous part, at x equals 5 and at x equals 7, right? That's where those intersect each other. That's where f prime is equal to 1, which will make g prime equal 0. So at x equals 5, x equals 7. Now I need to figure out the values at the endpoints and at the critical points. Now, there's an alternative solution that's actually probably a little easier, and that would be that you just show that g prime changes from negative to positive at x equals 5. And if it's the only critical point, then it must be the absolute minimum as well. But I'm going to use the candidates test. I'm invested. I'm going to make a table. I got x, I have g of x. We found most of what we need in previous parts, right? We need f of 0 minus 0. But f of 0 from part A was 3 plus 2 pi. So that's going to just be 3 plus 2 pi. For f of 5, we found that in part A as well. We got that was f of 5 is 3.5, but then minus the x-coordinate, so minus 5. So that's negative 1.5. And then at 7, we have to actually do some work, right? So it's going to be, remember, f is 3 plus the integral from 4 to 7. So I'm going to do 3 plus the integral from 4 to 7. Basically, I've created another problem here where I need to find f of 7. So I'm going to find f of 7 by doing 3 plus the integral from 4 to 7 of f prime. And then I'm going to subtract 7 because I have to subtract x. So this is going to be, that region right there is 2, and that region is 1.5, so 3.5. So it's 3 plus 3.5, and then minus 7. So that's 6.5 minus 7, that's negative 0.5. And so I'm going to say, therefore, the absolute minimum is negative 1.5 at x equals 5. That's the entire question. Okay, in this video, we are going to do number 4 from the Calc AB and Calc BC 2022 AP Calculus exams. And it's a table problem where you do kind of typical table problem things. So let's look at the problem. An ice sculpture melts in such a way that it can be modeled as a cone that maintains a conical shape as it decreases in size. The radius of the base of the cone is given by a twice differentiable function r, where r of t is measured in centimeters and t is measured in days. The table above, or below in my case, gives selected values of r prime of t, the rate of change of the radius over the time interval from 0 to 12. All right, part A is weird because they tell you exactly what to do. They say approximate r double prime of 8.5. Usually that's where the question just stops, but this continues. Using the average rate of change of r prime over the interval from 7 to 10, show the computations that lead to the answer and indicate units of measure. All right, so average rate of change is algebra 1 slope. So we're going to say that r double prime of 8.5 is approximately, they told us what to do, use the average rate of change on 7 to 10. So it's going to be r prime of 10 minus r prime of 7 over 10 minus 7. And then we just have to pull values from the table. So r prime of 10 is negative 3.8. R prime of 7 is negative 4.4. I feel like in recent years they've been using a lot of decimals on the non-calculator section as if to emphasize that you don't have to simplify, and maybe you should never try to simplify these numerical values. So we're going to sub in. So this, our calculation, is going to be negative 3.8 minus negative 4.4 over 3. So according to the rules, we do not need to simplify that, and we shouldn't, because we're probably going to get it wrong if we do. Not necessarily, but I mean, think of all the pressure you're under during the exam. So just leave that and throw your units on it. But if you don't stop there, you do get negative 0.6 divided by 3, which is negative 0.2. And then our units are going to be the units of r prime, which are centimeters per day, divided by the units of time, which are days. So I'm going to write that as centimeters per day per day. You could also do centimeters per day squared. I just think it's harder to interpret that, so I always write centimeters per day, and it's totally fine. All right, let's look at the next one. Is there a time t between 0 and 3 for which r prime of t is equal to negative 6, and we have to justify our answer? So when I see this, I usually think this is either going to be mvt or ivt. Since the table that I have is for r prime of t, I'm thinking that it's going to be ivt. If the table that I had was for r of t, I would think mvt, because mvt moves down a level and ivt kind of stays on the same level. All right, so to use ivt, I need r prime to be continuous, and therefore I need to establish that r prime is continuous. Well, they gave us that information indirectly by telling us that r is twice differentiable. So I'm going to start with that. So I'm going to say, since r is twice differentiable, that means that r prime is differentiable. And if r prime is differentiable, It is therefore continuous. So I've established that R prime is continuous, which means intermediate value theorem applies. All right, now I just need to, they told us from 0 to 3, so we only have to look at those. I'm going to find those values. So that's R prime of 0 is negative 6.1, and R prime of 3 is negative 5. So negative 6.1 is less than negative 6, and negative 5 is greater than, so we can do this. I'm going to write in my work, though, those values, because remember, we're trying to establish that we know what we're doing and show perfect work, or as close to perfect as we can get. You never know what's going to happen. So I've shown this, and now I'm just going to make the statement that R prime of 0 is less than negative 6, and R prime of 3 is greater than negative 6. Therefore, R prime of t must equal negative 6 for some t value between 0 and 3. And the reason I know that's true is because of the intermediate value theorem. So I needed the function to be continuous, I needed to be below the value, above the value, and therefore I would hit the value. All right, next up. This is going to be use a right Riemann sum with 4 sub-intervals indicated in the table to approximate the value of the integral from 0 to 12 of r prime of t dt. This is a pretty straightforward problem. Again, though, because of all the decimals, I would definitely not simplify this answer. I would just write it out, and you can leave the product and sums and just move on with life and know that you got the point. Because if you simplify and you get it wrong, even if your work was correct prior to that, you will lose the point. You don't want to lose points needlessly doing things that you don't need to do. All right, so we're using a right Riemann sum. So the first interval, we're going from 0 to 3, that's 3. And then it's a right Riemann sum, so we take the right value, which is negative 5. Then we're going to go from 3 to 7, which is 4 units long. And we'll use the right endpoint, which is negative 4.4. Then we go from 7 to 10, which is 3 units long. The right endpoint, negative 3.8. And finally, we go from 10 to 12, which is 2 units. And then the right endpoint is negative 3.5. Okay, you should stop there. That's all you have to do. I personally have an issue with stopping, so I went ahead and I said that actually equals negative 51, but we should really leave it unsimplified. There's no reason to simplify that. Trying to hammer that home to everybody. You don't need to simplify those values. Maybe in the future they'll change that, but I kind of doubt it. All right, next up. The height of the cone decreases at a rate of, so it's the same, given information, that's why I'm not reading that. The height of the cone decreases at a rate of 2 centimeters per day. At time t equals 3 days, the radius is 100, the height is 50. Find the rate of change of the volume of the cone with respect to time in cubic centimeters per day. So they're just giving you the units at time t equals 3 days. And then they give you the formula for volume. They pretty much always do that, so you can kind of count on that. So what do we do? We are trying to find the rate of change of volume with respect to time. That would be dv dt. We're looking for dv dt. We also know volume is pi over 3 r squared h. All right, so I'm going to find dv dt, which means everything needs to be a function of t. So I am basically using implicit differentiation here, right? So pi over 3 quantity. I like to take that coefficient and just factor it out. And now I'm going to do parentheses. And now I'm really dealing with r squared times h. I'm going to use the product rule because it's a product. So first is r squared times the derivative of the second, dh dt, plus second, which is h, times derivative of the first, which is going to be 2r, and then dr dt. So that is using implicit differentiation. This is like a related rates type of problem, but implicit is how I view this. Now we need values to plug in. So we're going to go hunting through the problem. All right, well, we need dh dt, we need h, we need r, we need dr dt. Well, the height of the cone decreases at a rate of 2 centimeters per day. So that's going to be dh dt, and you're decreasing, which means that's going to be negative 2. Next up, we need h. Well, they tell us that the height is 50, so h is 50. We're going to need r, but that's given as well. So the radius is 100, so r is 100. And then we need dr dt, so we need to realize that the table gives us r prime of t, which is dr dt. So we need r prime of 3, which is going to be right there. And that'll give us dr dt is negative 5. All right, and now we're just going to sub in. So dv dt is going to be pi over 3, the quantity, and I'm just subbing in 100 squared, negative 2, plus 50 times 2 times 100 times negative 5. And you know what I'm going to tell you to do right now? Stop, right? Just throw the units on there. You don't even really need units in this because they gave them to you. Put the units in there, move on with your day. You save a lot of time. Also, this is kind of a gross one to simplify, and you don't need to simplify it. But of course I did. So you should stop right before that. You shouldn't do this, but if you do go on, you will get negative 70,000 pi over 3 cubic centimeters per day. So that's what we're getting there. All right, so that's the entirety of this question. All right, in this video, we are going to do number 5 from the 2022 Calc BC exam, and it's kind of like the area volume, but also improper integral and integration by parts problem. So let's see what we got. Figures 1 and 2, I didn't show figure 2 because I don't need it for this part. Figures 1 and 2 shown to the side illustrate regions in the first quadrant associated with the graphs of y equals 1 over x and y equals 1 over x squared respectively. In figure 1, we're going to let R be the region bounded by the graph of y equals 1 over x, the x-axis, and the vertical lines x equals 1 and x equals 5. And then in figure 2, we'll worry about that when we need it. Part A is to find the area of region R. So R is going to be our 1 over x curve, and we're going from 1 to 5. We're just finding area, right? So that's going to be the integral from 1 to 5 of 1 over x dx. Integral from 1 to 5, 1 over x dx. The antiderivative of 1 over x is the natural log of the absolute value of x. We know that we're between 1 and 5, so we know that that's positive, but, you know, whatever. We put the absolute value. Then when we plug in 5, we know the absolute value of 5 is 5, so we don't need absolute value, so we get the natural log of 5 minus the natural log of 1. The natural log of 1 is 0, or you could think of it as condensing the logs, and you get the natural log of 5 over 1. Either way, we get natural log of 5 as our answer, and we're moving on. All right, R again, so the same deal, is the base of a solid. For the solid, each x at For the solid, at each x, the cross-section perpendicular to the x-axis is a rectangle with area given by x e to the x over 5. Find the volume of the solid. So this is really nice. We are given the area of a cross-section, and to find the volume, all we need to do is integrate that. So we're just going to integrate from 1 to 5 this area of a cross-section. So x e to the x over 5 dx. Now, this is an integration by parts problem, so we need to pick a u and a dv. Generally speaking, you try to pick u so that the derivatives will go to 0, but you also always have to be cognizant of the fact that you need to integrate dv. So if you can't figure out how to integrate dv, that can't be dv. But in this case, I'm going to let u equal x. I'm going to let dv equal e to the x over 5. Now I'm going to find du to be dx. And v, so there should be a 1/5, so I'm going to put a 5 e to the x over 5. You can work that one out with u substitution on the side if you need to. You can actually just let u equal e to the x over 5, and it will work out for you, but that's what we have for v. Now, integration by parts is uv, so it's going to be x times 5e to the x over 5, so like that. And then we're evaluating from 1 to 5, minus the integral of v du, so 5e to the x over 5, and then dx. All right, so now I'm going to use the fundamental theorem on this first part. So I plug in 5, and I get 25e to the first. I plug in 1, that's going to give me, so minus, plugging in 1 is 5e to the 1/5. Okay, that's the first part. Now minus, I still need to integrate this thing. So there should have been a 1/5, so there's another 5. So we have 5 times 5 is 25, e to the x over 5. And then we're going from 1 to 5, and we're going to sub in. So we still have this, purple parentheses. And then minus quantity. I plug in 5, I get 25e. And then minus, I plug in 1, I get 25e to the 1/5. Now, if you look at, I think you can leave this here, but I'm a little uncomfortable leaving this here because there's like a lot of stuff that cancels. Well, at least 2 things that cancel. So I went ahead and I simplified this. The 25e minus 25e is gone. You have negative 5e to the 1/5 minus negative, so plus 25e to the 1/5. So overall, this just becomes 20e to the 1/5. So I chose to simplify that one. I think it's a good move, and it's like not that hard. So it's not the same as when there are all the decimals and you're trying to avoid screwing that up. I simplified that. I have no regrets. All right, moving on. Now, find the volume of the solid generated when region W is revolved about the x-axis. So W is figure 2. It's the unbounded region between the graph of y equals 1 over x squared and the x-axis that lies to the right of the vertical line. So we're dealing with 1 over x squared, and we're just to the right of the line. So this is going to be an improper integral because our upper bound will be infinity. So let's set it up. So volume is pi, the integral from 3 to infinity, and then we're just going to do like big R squared because there's no inner curve. So we get 1 over x squared squared. So this, we have to use the proper notation. They're big on notation with this one. So we have to change it to the limit as b approaches infinity of pi, the integral from 3 to b, and then 1 over x squared squared is 1 over x to the fourth, and I made it x to the negative fourth so I can integrate it more easily by just reversing the power rule. All right, limit b approaches infinity, pi plus 1 times the reciprocal gives me negative 1/3 x to the negative third. And now we're going from 3 to b. Remember, we can't put infinity as our upper bound there. That's not proper notation. We will lose points for that, so don't do that. Equals the limit as b approaches infinity. So as long as I'm writing b, I'm going to have to write the limit. And I'm now using the fundamental theorem. So I substitute b, and I get negative 1 over 3b cubed. I think that's the best way to write it. I mean, you could write negative 1/3 b to the negative third. It's more obvious what happens as b goes to infinity if you rewrite it as 1 over 3b cubed. So that's why I did that. Then minus, I have to plug in 3. I'm also going to rewrite this one. So this is going to be, it's negative 1/3 times 3 to the negative third. So it's basically negative 1 over 3 to the fourth, which is negative 1 over 81. All right, so what's happening here? As b approaches infinity, 1 over 3b cubed just goes to 0. So that gives you 0. And then you have minus negative 1 over 81. So don't forget the pi, and our final answer here is pi over 81. That's our volume. So finite volume, even though it's an infinite region. I've always found that at least interesting, if not just straight up bizarre. That's actually the entire problem. Okay, in this video, we are going to do number 6 from the 2022 Calc BC exam, and it is the series question. So, the function f is defined by the power series, f of x equals x minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7 plus plus negative 1 to the n, x to the 2n plus 1 over 2n plus 1 plus for all real numbers x for which the series converges. Now the first question is to use the ratio test to find the interval of convergence of the power series. So we're going to try to figure out all x for which this series converges. They're telling us to use the ratio test, so that's going to be the limit as n approaches infinity of the n plus first term. So we take the nth term and we replace every n that we see with n plus 1. So that's going to give us negative 1 to the n plus 1. Now x to the, we have 2 quantity n plus 1, that's 2n plus 2 plus 1 is 2n plus 3, over 2n plus 3, times the reciprocal of the nth term. So times 2n plus 1 over negative 1 to the n, x to the 2n plus 1. All right, now almost everything here just cancels out, right? If we go to infinity, we are just going to be left with the absolute value of x squared, which is really just x squared because x squared is always positive. But why did this happen? Well, the absolute values took care of the negative 1 to the n parts. And then 2n plus 1 over 2n plus 3 as n goes to infinity is just 1. So that part also cancels itself out. And we're just left with x to the 2n plus 3 over x to the 2n plus 1. They differ by x to the second. So that's where that came from. Now we know the ratio test, we definitely converge if the ratio that we get, which is often called rho, is less than 1. So we know that this series converges absolutely between negative 1 and 1. Now what we need to do is test the endpoints. So to test the endpoints, we go back and we substitute them, right? So we just say at x equals negative 1, our series is going to become the sum from n equals 0 to infinity. I don't even know if you need to put the n equals 0 there. You could probably just go the sum to infinity. But if you look at it, it definitely is starting at 0, because if you plug in 0, you get x to the first. So it starts at 0 to infinity. If I plug in -1, I got to kind of work this out, right? So I'm going to have a -1 to the n, then I'm going to have a -1 to the 2n plus 1. That's -1 to the 3n plus 1. And now if you think about it, when n is 0, that's -1. When n is 1, that's 4. When, the exponent is 4. Basically, look at the exponent, right? The exponent goes 1, 4, 7. It's alternating between evens and odds, which means this is still alternating. That's the key thing. So I'm going to say that my series becomes -1 to the 3n plus 1 over 2n plus 1. This converges by the alternating series test for sure. Now, I don't know if we necessarily need to write out the reason for that. I mean, it alternates, the terms decrease in magnitude towards 0. That would be what I would write if I thought I needed to write that. But I don't think I need it. I think I can just say that this converges by alternating series test. Now we need to test at x equals 1. So at x equals 1, you just get -1 to the n over 2n plus 1. That one is definitively going to converge by the alternating series test. And so we have both endpoints converging. So when the question is, what is the interval of convergence? The interval of convergence will be -1 inclusive to 1 inclusive. I like to write it as an inequality, but you could write it using interval notation if you wanted to. All right, next up. Show that the absolute value of f of 1/2 minus 1/2 is less than 1/10. So the absolute value of f of 1/2 minus 1/2 is saying the error. So we're just trying to show that the error is less than 1/10, but like the error doing what, right? Well, clearly we're plugging 1/2 into f, so x is going to be equal to 1/2. So now we just have to figure out how many terms of the series did they use to get 1/2 as the approximation. That's what we're trying to do. So I want to establish that this is a convergent series. I don't know that I really need to do this, so I'm not going to make you watch me write it, but I'm going to say at x equals 1/2, the series for f of x is an alternating series with terms that decrease in magnitude to 0. Therefore, it is a convergent alternating series. I'm just doing that to justify using the alternating series error, because I don't want to use Lagrange on this. All right, so now what is happening? Well, if we approximate f of 1/2 with 1/2, right? So we're using 1/2 as our approximation of the sum of the series. That uses only the first term of the series, right? We're plugging 1/2 in for x, which means we're plugging 1/2 in there, and we're saying we're done. That's our approximation. Well, if that's our approximation, the next term, or the magnitude of the next term, should be the maximum error. So now I just need to take 1/2 and plug it in here and show that the value I get is less than 1/10. So how do I write that? Well, I'm going to say, therefore, the error, which is the absolute value of f of 1/2 minus 1/2, is going to be less than the magnitude of that term. So I take 1/2 and plug it in, and that gives me 1/24, which is definitely less than 1/10. I don't know why they chose 1/10, like, whatever, good, right? Usually they choose something closer, like 1/20, but 1/10, definitely less than that. And then I didn't really explain why I was doing that, so I decided I should probably also say using the magnitude of the first term left off as our error bound. So that's going to answer the question. It justifies it. All right, let's take a look at the next part. The next part's great, by the way. Write the first 4 non-zero terms and the general term for an infinite series that represents f prime of x. It's a power series. It's like designed for the power rule. We're just going to use the power rule to find this. So f prime of x is going to equal. So we look at the first term. It's x. We take its derivative. We get 1. We look at the next term. It's negative x cubed over 3. We take the derivative. We get minus x squared. We go to the next term. X to the 5th over 5. The derivative is plus x to the 4th. We go to the next term. The derivative of this is minus x to the 6th. Now we have to go to the nth term and take the derivative. You bring the exponent down, so you bring 2n plus 1 down. It cancels with the 2n plus 1 in the denominator, and we're going to get plus ... plus. -1 to the n stays, x to the 2n because you have subtracted 1 from the exponent. That's the entire part. But we do need this for the next part, so I'm going to copy it over. I don't know why. There we go. Okay, so use the result from part C to find the value of f prime of 1/6. This is f prime of x, right? That's our thing that we got in part C. I brought it over. I noticed immediately this is geometric. Since this is geometric, we know how to find the sum. So the sum of a geometric series, an infinite geometric series, is the first term, which in this case is 1, divided by 1 minus the common ratio. The common ratio here, we have -1 to the n, we have x to the 2n. The common ratio is -1 times x squared. So that's just -x squared. You can also get that by doing -x squared divided by 1, or x to the 4th divided by -x squared. Divide consecutive terms, and you will get the ratio. So it's minus the quantity -x squared, which means that f prime is 1 over 1 plus x squared. And then the question is, find the value of f prime of 1/2. I'm just going to take 1/2 and plug it in. So f prime of 1/2, I'm sorry, f prime of 1/6. I don't know why I read that wrong. I think I read it wrong every time. F prime of 1/6 is going to be 1 over 1 plus 1/6 squared. You can stop there, but I decided to keep going. It's not that bad. We just end up with 36 over 37, and that's it for this question, and I hope this was helpful, and good luck.